looks like some people are starting to come in here right now, so I'm just gonna start talking and say hello to everybody this evening. Thank you for coming back. I'm gonna be flying solo again tonight. My son's not here again tonight, so that's starting to become a regular thing. I have to get after that boy. Anyway, tonight what we're going to do is we're going to talk about this Ram Air 5 engine that I shared on Facebook, and I've gotten several people that have messaged me and wanting to know about this engine, which it is a pretty cool deal. It's a pump gas. It is 535 cubic inches, and it's an all aluminum engine. It's got a all Pontiac aluminum block. The bore is 4,350. The stroke is 4.5 inches, so it ends up being 535 cubic inches. Of course, it's got my DCI Motorsports Ram Air 5 head on it. Hello, Philip. Hello, John. Yeah, freedom. Thank God that our election went the way it did, and hopefully we get our country back and things start turning around for everybody, and we can reduce gas prices, grocery bills, and our cost of living radically here in the next. It's going to take a while, guys. Don't think that President Trump's going to be able to get in there and in a couple of days he's wave his magic wand and everything's good. It's going to take a while, but you know what? That guy, he assembled a super dream team, and if anybody can do it, it's President Trump. So I got complete faith in that man. He proved to me what he's capable of the first 4 years he was in. So at least this 4, let's hope that he can quadruple what he did in the first 4. Hey Tim, hey Jeff, thank you for coming back, guys. Andy, let's see, old school twist. Randy French, Elon Musk is. What is this? I don't know if that's Elon Musk or not, but anyhow, welcome Steve and Gattico. I'm thinking that's how you say it, Mark. Welcome aboard, guys. Thanks for showing up tonight. I appreciate it. But anyhow, like I was telling a few of the guys who are already here, what we're going to talk about is we're going to talk about this 535 that I shared on Facebook. I don't know, I feel like I'm out of sight here. So anyways, I was telling everybody it's a 535. It's got a 4,350 bore and a 4.5 inch stroke. The engine, I didn't build this engine. I sold the cylinder heads to a customer of mine, and he actually built the engine. And he did a little more work to the cylinder heads too. I sold them to him with the bowl cleanup and push rod or a gasket match, basically, is what we do. And he wanted to make a little bit more power, so he went in and did what is equivalent to my street and strip port. So now these heads that are on this engine, my as-cast heads will flow 400 CFM. Hey, Perry. And so anyways, as-cast, they flow 400 CFM, and they're capable of 700 plus horsepower in as-cast form on pump gas. These heads now flow 450 CFM at 700 inches of lift. With the port work that's been done to them. And I'm gonna, I think I shared some pictures in the discussion part of the introduction to the Tonight Show. You can see the ports in there. But anyhow, it's got this engine has a stainless steel valve in it, intake and exhaust. And they're 280 on the intake and 174 on the exhaust. The exhaust side, I think, flows right around 270, 280. So pretty hefty exhaust flow numbers, and especially for that valve size. And the I don't remember if I mentioned it or not, but the compression's 11-to-1. It's actually like 11.2 to 1 compression, but you can get away with that, remember, guys, because you got an aluminum head, and especially with this because it's got a aluminum block on top of it, so that this engine runs really cool, and it keeps the cylinder temperatures down, so it's not going to detonate. But you can run 93 octane on 11-to-1 compression with aluminum head all day long. It'll run good. We've actually run up to, believe it or not, 12.5 to 1. I don't like doing that for a customer because you really got to have your tune right on the money. If you don't, it's not going to, you could detonate it and you could hurt the engine. And I do believe Perry showed me some pictures of his engine, and it just failed, and it was because the octane fuel, he doesn't know for sure, but maybe at the pump they put the wrong octane in the high octane tank, and he got a tank of that bad gas, and it literally destroyed the engine. Detonation is very unforgiving. Whenever it does occur, it's not the same as pre-ignition. Pre-ignition is like whenever you shut the car off and it sits there and runs on after you shut the engine off. And the reason it'll keep running on is because it's got hot spots in the combustion chambers, and as long as the engine's turning over, it's going to keep pulling fuel through the carburetor. Now, fuel injection, it won't do that because, you know, it doesn't, once the injectors are shut off, it doesn't pull any more fuel. But the carbureted engines, they'll diesel. You know, that's pre-ignition. And but detonation's a different animal. What detonation does is it'll create two flame fronts. You'll get a hot spot on one side of the chamber, and you get the spark plug. And when they come together, it's detonating. It literally detonates like a bomb, and that's what creates, you know, too much cylinder pressure instantaneously, not controlled like it should be with the proper octane, where it burns evenly across the top of the piston. Whenever you got two flame fronts that bump into each other and they immediately blow up like a bomb, you know, the engine cannot take that kind of abuse, and it ends up breaking pistons, connecting rods, bending rods, hammer out rod bearings. It can break crankshafts. In Perry's case, and he's on here tonight, maybe he can share with you guys, but I think he actually broke a crank with it. So detonation's bad, bad, bad. So anyway, the engine's got 11.2 to 1 compression, which is very comfortable in 93 octane. This engine here, the camshaft in this thing was is an LSM custom billet roller cam, and it's a hydraulic profile. So, but this engine has solid lifters on it, which I do that all the time, and I recommend it to all my customers. The lifter in this engine is a Isky Easy Roll, which means that it has the bushing in it instead of needle bearings, which is more durable, especially for higher spring pressures. Now, when you run a hydraulic profile, the nice thing about running a hydraulic profile, it's an easier ramp, so it doesn't accelerate the lifter as fast or the valve, and you can run a lot lighter spring pressure. So, you know, typically with a solid roller cam and a solid roller profile, you might run somewhere around maybe 250 to 350 on the seat, and somewhere around anywhere from 600 to 1,000 pounds open. And of course, you know, that's high spring pressure. You know, the lifter and the wheel and the camshaft are supporting all that. And then on top of it, if you think about it, the rocker arm, the way it's designed to get the rocker ratio, the trunnion or the pivot point, they move it over to one side. So one side is really short and the other side is really long. And what that does on the short side is usually a push rod side. So you can only imagine, you know, you got a little bitty ratchet trying to break a bolt loose instead of a big long ratchet. And that's what's going on with the rocker arm whenever you increase the rocker ratio. So if you got a lot of spring pressure over here and you got a little bitty ratchet trying to push it open, you know what, it's gonna tear up Valvetrain parts. And puts a lot of load on the push rod, puts a lot of load on the lifter, puts a lot of load on the camshaft. The camshaft bearing creates a lot of harmonics in the Valvetrain. So you know, things like that, you know, you just don't really think about unless somebody brings it to your attention. So anyway, with that being said, this engine has a T&D shaft rocker system on it. And here in a minute, I'm going to pull the phone off here and I'm going to show you guys some of the components in this thing. And it's got a 1.75 ratio, rocker ratio, 1.75 to 1. And typically I recommend anywhere from 1.75 to 1.85 for these Ram Air 5 heads. Like our traditional Pontiac engines are 1.5 from the factory, unless of course you got a Ram Air 4, and those are 1.65. And I actually designed this Raymer 5 head to use the Harlan Sharp 1.65 ratio rocker, and on a stud. You don't have to run shaft mounted. You can run a stud mounted rocker on these heads too, which is a nice feature. I make guide plates for them. You can buy an off the shelf rocker for them, and an ARP rocker stud, and you can run a stud mounted rocker. You know, when you're building an engine with this type of cylinder head, though, because of the RPM range it's capable of, I really highly recommend that you use a shaft system anyway. I know some of you guys will say, you know, use a stud girdle. Stud girdles, if you think about it, in my opinion, because I've seen so many broken rocker studs with stud girdles, you're putting, you know, you got tolerances that stack up. All right, so whenever you got a line of rocker studs, and then you got holes in a rocker stud girdle, and then you got nuts that are machined and they might not be machined perfectly around. Now, if you got a rocker stud that's just a little bit off, and you got a hole that's a little bit off, and you got a rocker nut that's a little bit off, and then this one over here, it's this way, it's going to put more stress on the rocker stud. And I see a lot of broken rocker studs with stud girdles. I've seen less broken rocker studs without stud girdles than I have seen with stud girdles. So what's that tell you? I don't think that's a real good setup. You know, in theory, it sounds like a great idea. And I know some of you guys are going to say, oh, I ran them for years and never had any trouble. Well, you've been lucky, because I'm telling you, I have done this a long time, 43 years, and I've seen way more broken rocker studs with stud girdles than I have without them. And so I don't, if the guy doesn't want to do a shaft rocker, I just don't run a girdle. We just run a good stud, like an ARP stud, and make sure we got the right valve spring in it, and can try to control the Valvetrain so it doesn't create a lot of harmonics and break a rocker stud. That's how I like to do it. So, but this shaft system, you know, I think I showed you guys shafts last week whenever I was showing you my Raymer 4 deal. That the shaft system, there's very little flex, and there's a lot of advantage to that too. And I might have mentioned it last time, is the you know, when you have flex, if your rocker stud flexes a little bit, you're taking away lift. It's not going to be able to push the valve down as far. So, you know, if you're pushing it away, see how the rocker is going to move up. So you're going to lose a little bit of lift with the rocker stud flexing. With a shaft rocker, it can't really move. I mean, it's kind of pretty much stable there. I mean, the stand can move maybe a little bit because, you know, they're aluminum cylinder heads, but not as much as a rocker floating out there in space, you know, and on a stud. So you can lose, believe it or not, as much as 40 thousandths of lift at higher RPM because rocker studs flexing that much. And that's why guys want to use a stud girdle. But again, that's why the rocker stud breaks, because you got that flex going on, and then the rocker next to it may not be open, and this one isn't. It's flexing real hard, and this one's already tweaked this way. That's what happens, especially with a hardened stud with like an ARP, which is what you want. You want a hardened stud. You don't want a soft stud. And the stud will snap because it's hardened. And so again, I don't like stud girdles. It's just not my thing. So, but hey, Mike, see, Mike showed up. I missed a couple of guys there. Sorry, guys. I don't have my son to watch all you guys coming on tonight, but. Anyways, this engine's got shaft rockers on it with a 1.75 rocker ratio. It has a, I think it's got a pack spring. We only use, yeah, it does have a pack spring. We only use pack or PSI springs. And there's only a couple spring manufacturers in the whole world. Everybody thinks that Camshaft makes their springs. They don't. They buy them from pack. Or PSI. Manley, they buy them from PAC. Howard's, they buy them from PAC or PSI. They just repackage them and put their name on them. It's it's just what they do. That's nothing wrong with that. That's how the industry works. So there's only two major high quality spring manufacturers in the world, and they're PAC and PSI, and that's who I use. They're higher quality, so you're going to pay more money for them. You know, what they do, if you're buying their name brand, their first line, the they x-ray the wire, they stress relieve the wire. There's a lot of processing that goes through, especially when they're putting their name on it, because they don't want it to break, of course, and ruin their reputation. Not saying they don't do that for Comp or Howard or whoever. I think what happens is, like Comp Cams or Howard, whatever, they'll spec to that company, PSI or PAC, hey, this is how I want you to process my spring. And tool steel retainer, which is a little, it can be machined a little bit thinner than like a chromoly steel retainer, which reduces weight. It's not as light as titanium, but it's still a good idea. But it's really a good idea for a street car, because on a street engine, titanium is a wear product. It's kind of like aluminum. It fatigues with cycling after a while, and it can break, which is kind of shocking to me that GM puts titanium valves in somebody really wants to get a hold of me. But anyways, I'm surprised they put titanium valves in the Corvettes and stuff, because that's a wear part and it can break. And I'm thinking that with a car that you're going to warranty for, you know, I don't know how long a Corvette's warranty for, 36,000 miles or whatever, I wouldn't put that kind of a part in. But anyhow, that's another story. So anyway, we got a 175 ratio rocker, and we got a LSM billet roller cam in with a hydraulic profile lobe on it, which is easier on Valvetrain, it's easier on the springs, and you can use a lighter spring pressure, so you don't have to put all that stress on the Valvetrain. And the cam that's in this, whenever it made, it actually made like, I think 846 horsepower. I told everybody 850 on Facebook. I lied. I'm sorry. It's 4 horsepower shy. But anyways, the camshaft is 258, 274 at 50, and it has a 435 lobe. So with the 175 rocker ratio, it ends up being like 730 or 735 lift is what this camshaft gross lift, not net, because you're going to have deflection and loss from flex or whatever in the Valvetrain. So, you know, a net lift might be, say, 725 to 730, somewhere in that range. But it's got this cam's got or the cam that they dynoed with it had a 110 lobe separation on it, and it was installed at 106. And so, you know, a lot of guys freak out when they hear a cam that size, because they're so used to factory stuff, where, you know, old factory stuff, not so much the new stuff, because it's starting to get pretty aggressive. They're starting to put pretty big lift on the newer cams from the factory, but and a little more duration too. But the duration on the intake at 258 degrees and 50 thousandths, to give you a comparison to like a Ram Air 4 cam, which a lot of guys consider that a big camshaft, is 230 on the intake. And so you're talking 28 degrees more. Now, something you got to know about this is, when you go to a roller cam, you can actually run a little more duration at 50 thousandths and still end up with kind of the same kind of characteristic as a flat tappet cam, especially a hydraulic flat tappet cam. Typically, I tell people, you know what, if you got a 230 degree intake hydraulic flat tappet cam, you want to run 20 degrees more with a roller cam, even a hydraulic roller cam. So if it's 230 from the factory and you want to pick it up or run pretty close to the same, then you need to run 250 on the intake, and it'll be pretty close to what a hydraulic flat tappet cam with 230 is. So this cam might sound big to people. The lift is big. It's 730 thousandths, but you can get away with that on the street as long as your push rods are straight up and down, And the other part of that is too, where the rocker, because I designed the geometry on these rockers. So what we did was we designed this so that whenever the rocker's moving, the push rod's hardly moving back and forth whenever it goes through the lift range. Some of these engines, the rocker push or the push rod, because of the rocker geometry, not having the pad right on the head, will make that push rod move a lot. Well, mine barely moves back and forth. So you don't have any angle this way, and you're barely moving it this way. So you're pretty much running that push rod straight up and down. So it doesn't put near the stress on that push rod as an engine that does not have the geometry designed properly. And I spent a lot of time on the computer doing that and getting this straightened out so that it would, the Valvetrain would be happy and run at high RPM without destroying itself. And so far, we have not seen any Valvetrain issues at all with these Ram Air 5 heads. The Valvetrain is really stable. The wear pattern on the tip of the valve is really tight, which is what you want. And so everything is really, really good on this right now. Not saying that you can't screw it up by putting a bigger lift cam in it. Once you get into, so that's another thing. So when I designed this head, I designed it so that it could be used for up to 800 inches of lift and be stable. Now, if you're going to push the thing past 800 inches of lift, then you know what? Then things might start happening, and you have to maybe do a little re-engineering and try to get that straightened out so it doesn't kill itself. But the way I have it designed right now, as long as you stick with an 800 or less lift, Brandon, the guy that works for me on his car, he's got that 67 Firebird. You might have seen it on my website on the chassis dyno. That thing has been up to as high as, I think we've revved that to 8,400 RPM. It's got an 880 lift cam in it. He drives it on the street all the time. Now, he did just break a rocker this year, but he's had that thing together now for 4 or 5 years, and probably we're running a little too much spring pressure on his deal. I think he's got somewhere around 370 on the seat, which we're going to reduce that radically. We found out with these Ram Air 5 heads, but especially the hydraulic profile cam, you only need about 180, 190 pounds of seat pressure. So Brandon's got literally double what he needs, and that's what's breaking the rocker arm. It's not the lift, it's the spring pressure. Because when you have a spring that's got 380 on the seat, open is going to be like 1,100 at 880 lift, or maybe even 1,200, and that's what's breaking the rocker arm. Plus, he's got an aluminum rocker on there, and like I was telling you guys last week with the Ram Air 4 stuff, with the Ram Air 5s, and I don't have it on my Ram Air 4, but on the Ram Air 5 stuff, we use a steel rocker. And steel rockers, they're pretty much indestructible, especially when the Valvetrain's really good like these are. So anyway, that's where we're at with this. So it's got a 730 lift, 258, 274 at 50, 274 at 50, and a 110 lobe separation. So the cam's not real crazy, I don't feel. Compression's not real crazy. The cylinder head is where your horsepower's at. And the reason that this thing is making the power that it's making is because of the cylinder head. When you have a port that's big enough to put my Coors Light can into, and it still maintains torque at 3,000 RPM because of the airspeed, because of the way that I designed the intake port, you're going to make power with a smaller cam and less compression. And so 850 horsepower, I hear guys say it all the time about my Tiger head. Now it's easy to make 1,000 horsepower. It's like falling off a log. Well, I'm going to kind of coin that a little bit and say, you know what? Now it's easy to make 850 horsepower on pump gas with the Ram Air 5, DCI Ram Air 5 head. It's like falling off a log. It's not really. You got a little more involved in that, but now we're getting scienced out. It's really not that difficult for somebody to call me up and say, hey, Don, I want to make 850 horsepower. Can you send me a top end package? Yes, I can. I know what camshaft we need to use. I know what the heads need to flow. I know what rocker ratio, what lift we need. And basically that's what you need in the compression ratio. And then you guys can buy this stuff, bolt it on your engine, and make the horsepower we're making on the dyno. And so this engine, it's got a lot of nice stuff in it. This is a high end build. It's not a cheap build. That's another thing we're going to go over tonight too. But the engine's not stupid crazy. I mean, it's not like something that is going to require somebody with a lot of ciphering is the best way I could say it, figuring things out. You're gonna, it's pretty much scienced out for you guys. You can bolt this thing together and make 850 horsepower, and it's not real crazy. You can drive it on the street if you want to because it's a pump gas deal, and that's a good thing because, man, when you can build that kind of horsepower on pump gas, especially with today's fuel prices for race fuel. I haven't bought any in a few years. I haven't bought race fuel a long time, actually, I'll be honest. But I hear my customers talk about it, and they're talking, anywhere from I think $13 to $23 a gallon for racing fuel now, which is just astronomically high in my opinion. Back whenever I was buying race fuel, it was $3.70. What we're paying for pump gas now is like $3.75 a gallon back in the '90s. But so switching over to pump gas and running this thing on pump instead of race fuel. And that makes a lot of sense, and it saves you a lot of money if you're going to be at the track a lot, or if you're going to drive it on the street too. You don't want to run racing fuel on the street; it's expensive. And so, with this package, you don't have to. So that's that. I think I do know the header on whenever you run the header on this, because I sold the header to them too. It was a 2-inch tube, primary tube, with a 3.5-inch collector, and it's nothing trick. It's not a stepped header. It's not a merge collector, or doesn't have anything tricked onto it. It's just a standard about a 32-inch long tube, primary tube, going into a 3.5-inch exit collector. So the headers aren't real crazy. But anyways, the trickiest part of this whole build is the cylinder heads, and but the expense comes in when you're building an engine like this. Partly because this is one-off. You're talking about a Ram Air 5 engine. Ram Air 5 engines are not like traditional Pontiac engines, and because of that, you got to have a different camshaft, got to have a different intake, you got to have a different set of headers. It does take the same lifter, so that's not a big deal, and you don't have to run an offset lifter with my heads. The valves are lined up with the factory location push rod cup in the lifter. But you have to have a different push rod because my heads are taller. That requires a different head stud kit because the heads are taller. Let's see what else would be different on this thing. Valves are different because the head's taller, so it takes a longer valve. But you have to do that if you want to flow a lot of air. Remember what I was telling you last week about the Ram Air 4 stuff? Line of sight. You got to get that, raise that port up so you get the line of sight at the valve. And there's a point of no return on that too. But if you can see pretty much 85% of the valve, the backside of the valve, the engine's going to run pretty damn good. And especially if you can see it from the plenum up where the carburetor's at, then it's really going to run good. So again, like I was telling you guys before in past podcasts, it's all about the whole combination. It's not just one part. So you can't just buy my head and bolt any kind of intake on it. And I'm going to show you something here in a minute that makes me really scratch my head because it's crazy to me. But anyway, you'll see what I mean in a minute. But anyhow, line of sight is the best way to make the most horsepower. And the only way you can do that is by raising the head up or raising the intake port up so you can get a straighter shot at the valve. And when you do that, it requires a longer valve. It requires a lot of different things to make it work. So anyway, I'm gonna, I don't know what the torque is on this thing whenever he dynoed this. I think, but I'm not 100% sure. It was somewhere around, it was around 650. It might have been 670 or 80. I don't know that for sure. I am going to try to get the dyno sheets on this engine from the guy that dynoed it and share those with you guys. But I don't have those right now, unfortunately. I wish I did. But the guy that I'm referencing on this engine, he's not a bullshitter, so I know he didn't. He's not making up these numbers. And again, these are flywheel numbers. They're not tire or at the tire dyno numbers. So they are going to be a little bit different than what you would get on a chassis dyno. So anyhow, this intake, I got to take a drink of beer. Getting the horse talking too much. Anyway, this is the intake that he used to make that horsepower. Now, I want you to look at that thing. It is literally flat. Now, this is a fuel injected intake. He had injectors put on the bottom of this, and they go in here on the bottom side of the port. And this is a fuel rail is what this is. But he put them underneath, not on top. And that's okay. It works because his idea or thought was he's going to shoot the fuel straight into the back of the valve. And, I don't know if that's good, bad, or indifferent. We haven't had time to really do a lot of testing on that. But it just shocks me how shallow the plenum is on this thing. I don't know if you guys can see that. It's not real deep. Let me see if I can stick my fingers in there. Yeah, so that's how deep this plenum is. It's not very deep. And the intake is flat. And it made that horsepower with this intake manifold. Now, the whole reason for this intake was because he wanted to keep it underneath the factory hood. So he had, I think Hogan made this intake. I think Hogan's who built this. And so I'm just blown away by how small the plenum is and how flat the intake is, and the fact that it's, it doesn't have a good line of sight. And for it to make 850 horsepower with this intake manifold, to me, I would have never guessed it. If Hogan would have sent this intake to me, I would have told him take it back and fix it, because I would not build this intake manifold like this. But it obviously works, and that was with a carburetor. They didn't dyno this thing with fuel injection. They dynoed it with a carburetor, and I do believe it was a 4150, not a Dominator. It was 1,000 CFM, but it was a 4150. Now, we're going to have a podcast on that. I'm not going to be able to talk about it tonight because it's too in depth. But throttle plate diameter is huge. Even if you got a Dominator and a 4150, okay, so this one here is a 4150, and a Dominator's got a hole that big, and they both flow 1,000 CFM. Which one do you think is going to move more air? I don't care what the flow bench says. I go by the diameter of the throttle plate, and that's what's going on with your high-end carburetors now. Everybody doesn't go by CFM anymore. They go by throttle plate diameter. And we'll go over that in a podcast. I'll show everybody what I mean by that. But anyway, this thing, he dynoed this thing with a 4150 style 1,000 CFM carburetor, which in my opinion was way too small. So, but it is what it is. And actually, he was kind of disappointed in the dyno numbers on this thing, and I'm thinking the dyno numbers are phenomenal because of the fact that of the restrictions. We got an intake, to me, is not very good. Carburetor's not very big, and other than that, I mean, he did okay. The heads are pretty decent and everything, but we got two limiting factors here, and how in the world can something this shallow and not straight into the intake runner make that kind of power? So that's pretty impressive in my opinion to do that with this intake manifold. So I'm going to pull my phone off here real quick and show you guys what the so Frankie name car for edit, I swear I make it. So anyway, let me pull this phone off of here, and I'm going to turn you guys around, and I'm going to show you some of the goodies on this thing. All right, so you see the stainless steel shaft rocker. Again, this is the shaft going across here instead of a stud, which would be right here in the center of this rocker. So now you got a shaft going this way, and what that does, if you can see it here, it allows that rocker to not flex as much. And again, these are steel rockers, so you're gaining a little bit there too. And what they've done to try to lighten them up is they've scalloped them out right here on the tops, and they're on the bottom too. And they made these things a lot narrower than you would an aluminum rocker, because you don't, steel's stronger than aluminum, so you don't need all that extra material. So, but these are a 1:75 ratio, and these are made by T&D. And I don't see any numbers on these things, but so anyhow, these are the Cam's tool steel retainers I was telling you guys about. And you can see they're quite thin where they mount on the spring there compared to like a regular steel retainer right in here in this area right here. And so that reduces a lot of weight. Plus they scalloped them out here on the top too. So, that reduces weight on these retainers as well. And you want to reduce weight from this side of the rocker down to the valve. Anytime you can reduce weight in this side of the rocker and the Valvetrain, even the valve spring. So if you look at these springs, the coil diameter, that's weight and mass, and you got to move that mass and weight. So anytime you can reduce that spring diameter and still maintain the spring pressure you want is going to help reduce harmonics and at high RPM with these engines. So you want to definitely do that if you can too. And then the other part of it, the equation is the lock in here. So this is a retainer, this is your valve spring, and then your locks are inside here that hold the retainer on the valve itself. And all those parts, you can buy them in titanium. You can even buy titanium springs. I think the Pro Stock guys, they run titanium springs. That's how critical it is. But these are not. These are a steel spring. And this is a steel retainer, and these are steel locks. But you can buy all this in titanium and reduce the weight even more than what we have here. And then you can buy a valve in titanium as well. Or you can buy a hollow stem valve too. Now these are stainless steel in this engine, and they're severe duty, so they're a little bit heavy. To give you an idea, my intake valves weigh somewhere around 124 grams because of their length. They are a little bit long because they're 6,450 overall length. Factory valve is like 5. The ones we typically use are 5,230. So we're talking a little over an inch or an inch 200 longer in valve length. But the other thing you got to think about, it's valve stem length. It's not, the head is where all the weight's at, down at the bottom where it seats against the valve seat in the head. So we actually cut one of my valves because I had one of my competitors say that my valves are not going to work because they're too heavy. And so I thought, all right, we're going to find out how much heavier they are. So I took one of my 6,450 long valves, and we cut the stem down to 6,230 or 5,230 like we normally run. And it only made like, I don't know, 8 grams difference. I know it's 8 grams, don't get me wrong, I get it. But the thing of it is, it's not radically different. And if you're that concerned, what we can do is we can either run a hollow stem or we can run a titanium valve. And you can get the 6,450 titanium valves down to, I've seen them as light as 94 grams, depending on how you design the head. So you can lose a lot of weight on a valve with titanium. And just a little side note too, the NASCAR engines and the valves in those cylinder heads, because they've raised the ports up on those guys are running over 6-inch long valves in some of those engines too. So if it was such a big detriment, NASCAR sure as hell wouldn't be doing it. So anyway, this is my cast intake manifold that's on this thing, and you can see what I've done is I put a stuffer inside of this thing. That's what I call this ribbed area in here, and what that does is it helps divert the air and fuel and keeps the fuel energized or atomized, so it doesn't fall out of the air and lose suspension and turn to liquid again. So it's like an agitator. What it's doing is making turbulence in there to keep that fuel suspended in the air, and try to get some, get the fuel or the air not to cling to the wall. But this one here's got a single 4 top plate on it. I've got to move my beers out of the way here. It's set up for 4150. That's what this is. And I make them for Dominators. I make them for 2.4s like on Brandon's car. We make them for tri-powers. We can make it for any configuration you want, because the top plate, if you see, it bolts on. So I can make any top plate you guys want. And, so a lot of guys, when they first saw my intake, and I'm going to back off here a little bit so you can see the whole thing. A lot of guys, when they first saw my intake, they're saying, man, that's got a big plenum. And it's really not that big when you realize that it's not real deep, right? And actually, being that it is not real deep is actually a detriment to this thing. I really would like to make this intake manifold way different than what I did. But everybody wants this thing to be under the hood under the factory hood. And I get it, guys. I totally get it. But we got to get past that. We got to figure out a way to get around that. One of the things I thought about doing is making my own shakers. And you'd have to cut a hole in your hood. Don't get me wrong. But you could, if you have a GTO, you could buy a Le Mans hood, and we can design a shaker, and you can cut the hole in the hood and gain the hood clearance we need, and that way the engine will run like it's supposed to. It'll be cool. People will think it's cool, and you're not ruining a GTO hood. Now this is an all Pontiac aluminum block, all right, and I think this is one of the later versions. The first ones, they would only hold up to about 700 horsepower. The later versions, they improved the strength of this thing quite a bit. And now I do believe that these things are good for 3,000 horsepower, I think. So that's a big improvement. The IA blocks, too, they got screw-in studs for the oil filter adapter, oil lines. You can put screw-in lines in there. The freeze plugs are screw-in. Sometimes that's a pain in the ass. It may not be a benefit, but it's a feature that is involved on these. This engine too, you can see the tab sticking out there between the head and the block. This has got Cometic head gaskets on it. It's got a Canton pan. This is not a trick pan. This pan is an off-the-shelf pan that Canton sells for like $300. And so it's not anything trick there. It doesn't have any kickouts on it or anything crazy going on there. A little thing that I done that I just wanted to make my stuff unique is the now you can see too, I got injector bungs on my intake manifold, so we can machine those for injectors, or machine the intake for injectors. So and we do that quite often actually. We use the Edelbrock ProFlow 4 and we machine my intake for the ProFlow 4 system, and make it work with their ECU and throttle body and everything. And but anyhow, one of the things that I did, because these heads from the factory had number 44 on them on the 400s, so I put the 44 on the center like the factory did. These things here, people ask me what these are all the time. It didn't quite turn out quite the way I wanted it to, but what these are is the factory had a pad there, and then they had an injector boss for an air pump for emissions. And why they were thinking this was going to try to meet emissions, but what they were doing, what an air pump does is it blows oxygen into the exhaust port, and any fuel that doesn't get burnt in the combustion chamber, it supposedly helps it burn whenever it's in the exhaust. So I did, you know, I tried to make these things kind of look factory, even though they're taller than factory. I even made sure that the features from the factory were on the end of the head. Now I also did, what I also did to these cylinder heads is I got all the bolt holes for the late and early. So this will work with 64 to 70 brackets, and it'll work with 71 and newer brackets. So you can use any bracket on this. So if you want to buy a CVF or a March pulley system, the heads are designed to use all that stuff without having to make anything work. It's all bolt on. Now I had to design a water crossover for my intake manifold, because if you look at this, see, there's hardly any room in between the intake and the water crossover here. And so what happened was there was nothing that was going to work with this intake because of how big it is. And I was trying to get that plenum big enough so that we wouldn't make these end cylinders starve for air. So I ended up designing this water crossover, and I do sell these. It uses a 1965 tri-power water neck, but it's got the bypass on it, you know, that goes right into the timing cover, the backside of the timing cover, and of course that's where the thermostat is here, and then we have it drilled and tapped. Now looks like Brian, the guy's named Brian that had this. It looks like he tapped it again for another fitting here for a sensor, but we put one hole in it when we design it so that you can put a temperature sensor in it. And the cool part too is my heads take a factory valve cover, doesn't take a special valve cover, and as you can see, you know, this one here, it clears the rockers fine. This is a sheet metal, but you can literally use a factory valve cover on my heads. I wish I had one here to show you guys. And the reason is because what I done, which is kind of cool, this valve cover rail here, I raised it up so that with a factory rocker cover, which is short, will clear these rocker arms. So I made the valve cover rail higher. And what that does too, it helps too, if you look inside of here, you can see the oil still laying in the head. So what that does is it keeps the oil down inside the engine too, so you don't get the oil leaks that you would with a factory head either, because the factory heads are real shallow here. Mine's pretty deep. And then you can see my oil return here. It's a little dark in here, but maybe we can see it on the other side here. Go over here. Yeah, maybe. I don't know if you guys can see in there or not, but anyhow, there's the oil return is back up in here. A lot of guys will buy my heads, and I don't have any oil returns down through the head. They're only on the ends. So, you know, guys will get these heads and they'll say, there's no oil return. Yeah, there is. It's hidden. It's down inside there. And I don't know if you can see it. Yeah, you might be able to see it. See it down there on the right-hand side down there. Next to the head stud. That's where the oil return is. And it's 530 thousandths in diameter. So it's a big oil return. And you don't, as you can see, there's hardly any oil in the head. And that's even when it's running, you don't get much oil up top. So this has also got an aluminum valley cover on it. I think I told you guys it's got easy roll lifters in it. They're an 842 diameter. You can put up to 904 or 927 diameter lifter in these engines, and we do a lot of times because anything you can do to make it durable and hold up for high RPM use, we like to do. But and the plugs are angled because of the combustion chamber design. It's a high swirl chamber design. I don't know. Anything else I can tell you guys while I got you? It's pretty much what we're doing here. I mean, it's not real trick. So let me stick the guys back in here. But that's what this engine consists of. 850 horsepower. The key factors, the reason it makes that kind of power is because of the fact that it's got a 450 CFM head, and it does it with pump gas. You know, now we some of you guys have been following me on Facebook and seen some of the stuff that we got going on with the Ram Air 5s that other people have built. Chris Urachko, he just finished up an engine for, well, he's been working on it a little bit, and I think he's going back to the dyno with it again, but he's got it's a 555, I think, cubic inch engine with a set of my Ram heads on it with my race board on those. And he's doing a drag and drive, so can't get real radical with a camshaft with something like that too, because you're going to drive it on the street. And they dynoed it and it made 11, I think it was 1160 or somewhere around there. And he's going back to the dyno again. He wants to make 1200 horsepower with it. And they're going to be able to run that on the street with pump gas, but it's like 12.7 to 1 compression. So when he's dynoing it, he is not dynoing it with pump gas. He's dynoing with racing fuel. But at 12.7, as long as you don't beat on it and all you're doing is cruising, you can get away with 93 octane and maybe have to put a little bit of octane booster in it. Or another thing you can do too is you can put water injection on it and it'll cool the chamber. And David Zard, I don't know if I haven't tried it yet. I bought a system. I'm going to try it, but he claims with a water system, water meth injection, you can run 17 to 1 compression on 89 octane. I don't know if I believe that, but we're going to find out. I'm not going to sell to a customer until I know for sure. But yeah, so So Jay Sharp is asking me about bolting these on a standard block. Yes, I designed my Ram Air 5 head to work on a minimum bore size of 4150, but you got to reduce the exhaust valve size down. And like this head's got a 174 in it, and you can get away with a 174 exhaust valve. The intake, I moved it way over, so it's not an issue. You can run a 2300 intake valve in this head on a 4150 bore, and it's not an issue. But the exhaust, I had to move it over because we wanted to make room for the intake valve. And because of that, it's really close to the cylinder wall, especially on a 4150 bore. So I tell everybody the minimum bore I recommend that you run on these is 4190. That way we can put like a 168 exhaust valve in these things. We can put as small as a 165 exhaust valve in it, and there's nothing wrong with that. We can run the throat at 94% on these, and it still flows 270 plus CFM. So I'm not afraid to do that. We can make and we can make big power with these. So, but yes, they will bolt on a factory block, and we've got lots of them out there that way. The engine that Brandon, the guy that works for me, it's a factory 455 block. Now his is 4.25 bore, but my wife's car, we've got a Ram Air 5 in it, and it is a 4185 bore, I think, on hers. And I've got a 168 exhaust valve in that. And then we got several customers that have these heads on 4180 bores, 455s or 400s. It doesn't really matter. Either one of those engines can be bored out to 4180 or 4190 pretty easily. Yeah, thank you. Yeah, that intake manifold, I struggled with that thing big time because anything I was going to come up with, it looked like that sheet metal intake, and I didn't like it. And when I first came out with these heads, man, and what's sad is that every one of these guys that talked me into making this intake manifold the way I did it, not one of those guys bought a set of heads. They all said, "Oh, I'll buy it, I'll buy it, buy it if you make the intake like this." And I made the intake like this. None of them bought it. Crickets right after that. So, I think they were just using it as an excuse because they couldn't afford the heads. And so I'm going to go over the cost of that real quick with you guys. To do a top end like this isn't for the faint of heart, and it's not for it's not for everybody. I'm sorry, it just is not. And I'm not trying to sell this as being the cure-all or the be-all for everybody. It is not. It's a unique deal that if you want to have something that nobody else has with Pontiac engines, and you want to make big horsepower, I mean, we can make good horsepower with Edelbrock heads. We can make 600 horsepower on pump gas, no problem. But if you want to make 800 horsepower on pump gas, you need a better head. And and I'm not saying you can't do it with Edelbrock heads. Don't get me wrong, you can. But it takes a lot of effort, and it's going to cost you way more money than if you buy the Ram Air 5 deal. And then the Ram Air 5, you got more real estate, so you can expand and you can make more and more power as you go, your addiction starts to kick in. And so, anyways, to do this top end and entry level, and the entry level includes complete heads, ready to bolt on, stainless steel severe duty valves, pack or PSI springs. We use a Dart steel retainer and 10-degree keeper. The heads will be gasket matched. They'll flow roughly 400 CFM at like 800 inches of lift. They flow right around 360 or 380 at like 600 or 700 inches of lift, which is a lot of air at that lift. The stud kit, which is an ARP stud kit with the studs, the nuts, and the washers. All the intake gaskets, the intake gaskets, the exhaust header gaskets, the intake manifold top plate gasket, the intake manifold with the stuffer in it, and the top plate for a 4150 or 4500 Dominator, the water crossover, the water crossover water neck, the a billet custom ground roller cam for whatever you want to run. I'll design it and I'll make it for your application. The stud mounted rockers, we use an ARP rocker arm stud, and that comes in the kit. The push rod guide plates, and they're good for 3/8 push rods because I made the holes big enough in the head so we can run a 3/8 push rod. Let's see what else. The headers, a 2-inch tube header with the 3.5-inch collector for the 67 to 9 Firebirds or the 68 to 72 A body, which is the GTO or Le Mans, and for 70 to 81 Firebird or F body. So it comes with the headers. So you're getting the intake complete with all the parts and components that go into it. The stainless steel hardware to hold the intake top plate on, hold the intake on the heads. The O-ring kit and gaskets for the water crossover. The water crossover. The stud, the stud kit, the ARP stud kit. The headers, header gaskets, intake gaskets, rocker arms. I provide you with a Harlan Sharp roller rocker. Let's see, the guide plates and the studs I told you about. Let's see, so pretty much everything. The only thing that and valve covers, I throw in my set of valve covers too. The only thing that you're going to have to provide when you buy this kit is you're going to have to provide the lifter and push rod. And the reason I do that is because some guys already have lifters, and you can run just a regular roller lifter. I highly recommend a solid, not a hydraulic. And then once you mock everything up, you guys are going to have to know what your push rod length is by checking everything. And that's why I can't provide a push rod, because if you deck your block or if we mill these heads to get the compression up or whatever, it's going to change. And so not one push rod fits all. They're not generic. It's got to be specific to this application because of how tightly I've designed the intake or the Valvetrain on this so that it doesn't flex the push rod. So you're going to have to determine the push rod length on your own once you get it all put together and mocked up. And then, so no lifters, no push rods, but everything else. Intake, water crossover, headers, camshaft, stud kit, gaskets, everything you need. I can sell you in the valve covers. I'll throw in a set of my cast valve covers. Everything is $11,500. So some of you guys know, because you've been doing this a while, you know that's a smoking good deal for a 700 horsepower, because as cast, these heads will make enough or flow enough to make 700 horsepower. And some of you guys know that you can spend $7,000-8,000 on a set of Edelbrock heads to make 700 horsepower. That's nothing else. You're not going to get no cam, no nothing. You know, you're not getting any other parts. So for $11,500 for headers, camshaft, heads, intake, stud kits, all the gaskets, everything you need except for lifters and push rods, rocker arms, the rocker arm studs, guide plates, everything for $11,500, guys. That, to me, I can't do it any cheaper than. I'm sorry. These are a high-end head. They're made out of 356A aluminum, and some of you guys may be aware of this. Philip the Third might know. I don't know, but there's different grades of 356 aluminum. You can buy A, B, and C grade, and then I think they got a junk grade too, but I'm not sure what it is. I don't know what the designation is. But we use 356A. We don't use anything but A, which is pure 356. They eliminate all the impurities. It's brand new. It's not recycled. And when you do that, it costs a lot of money. These heads are big. They're big chunks of aluminum. They're roughly about 10 or 15 pounds heavier than an Edelbrock head. And so you got to pay for that. And you're paying for quality. You're paying for high-end stuff. And you just can't do that kind of thing cheap. And I'm using high-end parts too. We're not using junk. You know, we don't use generic Chinese parts in these things. We use high-end parts. So for that kind of money to go and make that kind of horsepower on pump gas, guys, I'm sorry. You might be able to do it somewhere else. I don't know, but that's pretty cheap in my opinion. And I build a lot of engines. I've been in business a long time. So Scott Story, how are they with nitrous? You know what? I don't know. I don't see why it would be a problem. I mean, with the way that I designed the intake port, it's actually 2 ports. We call it a split port. And so if you jockey or position the injectors, the nitrous injectors just right, should work fine. I don't see any reason why it wouldn't. All you're doing is introducing a little more air and fuel, so I don't see why it would be a problem. Old school twist, Philip the Third. What colors? I don't know what you guys are talking about. OST, I'd use a crayon. Okay. I don't know what you guys are talking about there. You guys are bullshitting about something in the chat box there. Hey guys, it looks like we're at 7:30. My hour's up, so I hate to keep you guys any longer than I told you I would, but appreciate you guys coming in tonight and coming with putting up with me starting a half hour later. And something that I do is I do a lot of car inspections and appraisals for classic cars, and I had a big one to do, and it was about an hour drive from here. So, and I didn't know for sure if I was going to get back in time to do it at 6 o'clock, and that's why I started at 6:30. So I had to start the show a little bit. I could have probably started at 6 tonight, but I just wanted to make sure. So, anyways, get here a little late. But any prices on the Rammer 3 or 4 heads? I don't have any prices on the Rammer 3 and 4 stuff yet, guys. Hopefully, here in a couple weeks, you know, the machine shop that's got a machine, CNC machine heads for me, they had a machine go down and they had to have it repaired. So that held up process. Murphy's Law, you know what? Nothing ever goes like it's supposed to, and I know, and it's worse for me than it is you guys. Trust me, I know it's like watching paint dry, but you got to understand my side too. It's killing me. I got a lot of money tied up in these heads. I need to start selling them, and I want to get them done. So nobody wants these done more than me, and so hang in there. We will get her done. But anyways, I appreciate everybody showing up tonight, and hopefully my son will be back next week. And I don't know what we're going to talk about next week, but I'll find something fun to talk about. But thanks for coming tonight, guys, and good night.